Okay, well, we're talking about parallel and perpendicular lines. So parallel lines and it's their slopes. M1 equals what? For parallel lines, what is it? Their slopes are equal, same, equal. Perpendicular. What about how are their slopes related? Okay, so M1 equals a negative 1 over M2. A negative, the reciprocal, right? That's basically what we're looking at. So that being said, number 12 says the line y equals minus 2x plus 2/3. Is it parallel to the line y equals a negative 2x plus 3? What's the slope here? M1 is. What's the slope of that? What? Negative 2. Gage says negative 2. Everyone agree?
Yes.
What's the slope here? Are they parallel? By definition, they're parallel. Slopes are equal. So 14 says y equals 1/2 x plus 3/2. And it's saying, is it perpendicular to y equals a negative 1/2 x plus 3/2? So what's the slope here? What's the slope here? Negative 1/2? Are they perpendicular?
No.
Because they're not reciprocal, right? They're negatives of each other, but not reciprocals. So the answer here was no. The answer here was yes. So number 20. Here it's giving you a pair of points. It says the line that contains these pair of points, 4, minus 3, and 2, 5. And then there's another line that contains the points minus 2, minus 3, and minus 4, and 1. And it says, are they parallel? So what you're going to have to do to do that? Okay, and do what? If you found their slopes, you could figure it out, couldn't you? Okay, so if we do slope 1, we call that, and it's y2 minus y1 over x2 minus x1. So if we call the second pair 2, 5, y2, x2, y2, then this is going to be 5 minus a minus 3, right? And then it's 2 minus 4. So 5 minus a minus 3 is 8 over minus 2, right? Which is a minus 4. So if we take slope here, and I would take the second one and call it x2, y2, I would have 1 minus a minus 3, minus 4, minus a minus 2. The numerator is 1 minus a minus, so that's 1 plus 3 is 4. Denominator is a minus 4 minus a minus 2, so that's 4 plus 2 is a minus 2. correct? That's a minus 2. So if I did my math right, are they parallel? No, because their slopes are not the same, right? I'm pretty sure I did that, put my numbers in right. Okay, let's check and make sure that pretty sure I did my numbers right. So, any questions? (26) says find the equation of the line containing the point. So this point 2 minus 5 is on the line, and it's perpendicular to y equals 5/2 x minus 4. So we can't use, for that point 2 minus 5, we're trying to find the line through that point. We have a point, but we don't have what? Slope. So it's given us that other line so we can calculate the slope for the first line, right? This line right here has slope m1. We're not given it. This line right here has slope m2, and can we find it? What's the slope of this line right here? What? 5/2. Now, what's the slope? If 5/2 is the slope of this line, what's the slope of this line? Who's saying it? Gage? What'd you say? -2/5, right? Because they're perpendicular lines. So now we're done with this equation. We've used it to the extent we needed to do the calculation. So now what we have to do is we have to take the information we have right here and place it into our point slope formula. And we're going to go what? Minus what? Minus 5 equals m is what? Okay, and it's x minus 2, correct? So simplifying this, it's y plus 5 equals, I have to distribute that -2/5 through that, so it's a -2/5 x plus 4/5. Is that right? Now, I got to get rid of that 5 on the side over here, right? I think we'll get rid of this. So what am I going to do? Subtract 5 from both sides? Now, the constant terms are 4/5 and -5. How are we going to combine those? Common denominators, right? So what's the common denominator between 4/5 and 5? We have to build it, don't we? We build it with a 5 times 5/5. Now we got a common denominator. So now we have y equals negative 2/5 x. And now we got a common denominator of 5. We bring their 4 down, minus 5 times 5 is 25, right? Now notice this numerator is 4 minus 25. So what's in the numerator? Minus 21, right? So this is going to be a negative 21 over 5. And there's my equation, my line. Any questions on that? Anything? Okay, the next set of problems that says 29 and 30, the diagram over there on the right, this ball is being swung with a string and then let loose. Once it let loose, it goes perpendicular to the string coming from the origin, and the ball is swung from the origin. It'd be like a slingshot, right? And it says it's perpendicular. Now 30 says that this ball is let loose at a point 2-8. Which quadrant are we in? 2-8. First quadrant. So if I draw my first quadrant, and if I go 2 over, then I go 8 up, so my point 2-8 is going to be someplace up there, right? Now it says that 0, 0 is where the string is attached, and you assume it to be there. So then what you have that particular line right there that being swung. And then the perpendicular, it goes, the ball when it's let go goes perpendicular to that. Let's just say that that's perpendicular. And remember that this point right here is 2-8. So with that information, they want the equation of that green line. How are you going to get it? Can you get the equation of this line? You got this point, and that point given to you, right? Which is this thing right here. You can get that with that formula, can't you? y2 minus y1 over x2 minus x1. And we use the 2-8 as x2, y2. So it's going to be 8 minus 0 over 2 minus 0, which is 8 over 2, which is 4. So the slope of that line is 4. So with that information, can we calculate the slope of this line? okay? It's perpendicular, so if the slope of this line right here is 4, then the slope of that green line has to equal negative 1/4. And it's going through this point, so now we take our equation y minus y1 equals mx minus x1 and substitute the point and the slope in. Y minus 8 negative 1/4 x minus 2. Put a bracket on that. So we have y minus 8, distribute the 1/4, so it's a negative 1/4 x plus 1/2. We have to move that 8 over, so it goes plus. So it's y equals a negative 1/4 x plus 1/2 plus 8. We got to get a common denominator, right? 2 over 2. So now our equation is y equals negative 1/4 x plus, the numerator is going to be 1 plus 16 over 2. Here's my equation. 17. So there's my equation, right? You good with that? Okay, do you have any questions on problems? I'm going way fast in this class. So. Everyone good with what I've done so far? I'm going to talk about the quiz on Wednesday is going to be over 4, 5, 4, 6. So it'll be over this material. And then what's due is 4, 5, and 4, 6. I'll look at 32. It says the graph a sub 1x plus b sub 1y equals c1, and then a2 x plus b2y equals C2. It says if they are parallel, express A1, B1 in terms of A2, B2. So what did we say the slope here for this equation right here would be? M1 would be what? It's the numerical coefficient of the x term over the numerical coefficient of y. So what's the numerical coefficient of the x? A1. If you don't understand the terminology, it's what number is multiplied by x. A1 is, right? What number is multiplied by y? B1. In this one, the slope here, the x term is going to be what? What's the number multiplied by x? A2. Number multiplied by y is B2. Notice it says if the graphs A1x plus b1y is equal to c1, and if a2x plus b2y equals c2, if they're parallel, what would that be? M1 and F equals what? M2, that would say that A1 over B1 would have to equal what? A2 over B2. That's all we're asking for there. I'd ask you to look at your handout sheet, and there's a bunch of rules for exponents. So the first rule says if you have xm times xn equals x to the n plus 1, m plus n, m plus n. Now, that would be, if I put it in number form, if you had 5 squared times 5 to the 4th power. You see the bases of both 5, they're the same, so what you do, this is a times. You add the exponents. So it's the same as 5 to the 6th power. The next one they say xm to the nth power is equal to x to the m times n. So if we go 2 to the 3rd power to the 4th power, that would be 2 to the 3 times 4, which is 2 to the 12th power. All mean the same thing. Here's the next one, says x to the m, y to the n raised to the pth power is x to the m p y to the np. So if I had a base, if my x base was 5, if I have 5 squared, now I have to have a different base, y, 6 and a different number to the 3rd, and I raise it to the 4th power, then what this means is that I go 5 to the 2 times 4, 6 to the 3 times 4, which is 5 to the 8 times 6 to the 12. That's how you apply it. Next one says x to the m over x to the n is x to the n minus n, as long as x to the n is not equal to 0. Why do they say an x to n cannot equal 0? If you try to divide by 0, what do you get? No, undefined. You cannot divide by 0. So if we put x is 5, we put 5 squared over 5 to the 3rd power. What this is saying is that you can take 5 to the 2 minus 3 and get 5 to the negative 1 power. Now, that particular thing is the same as 1/5. And you can see if you got 5 squared over 5 to the 3rd, that's 1/5, right? You can use your positive and negative exponents. Now, this becomes an important concept. If you have x to the n, you can write that as 1 over x to the minus n. If you have 1 over x to the n here, you could go x to the minus n in the numerator. You can move your exponents on your bases wherever you want, wherever it's, necessary to do. And that's that next one over there. They're talking about x to the m over x to the n, and you raise this to the pth power. Then what you can do is you can go x to the mp over x to the np. And you can move those around all you want. Here's an important concept. X to the 0th. What is 0th power of any number? Always equals 1. It always equals 1. I just want to show you something here. If I go 2 to the first power, what do I get? 2. If I go 2 to the second power, what do I get? 4. If I go 2 to the third power, what do I get? 8. Now, if I go 2 to the minus 1 power, be careful, what is that? One over 2 to the first, isn't it? 1/2. 2 to the minus 2 power is what? 1/4. 2 to the minus 3 power is what? 1/8. So 2 to the 0th is what? 1. So if you were to graph this thing, this thing's going to graph 2 to the 0th power right in here is 1. So what you do is if you have x's minus 2, minus 1, 0, 1, and 2, and you go 2 to the 2 to the x. Well, this is a negative 1/4. It's not negative. This is 1/4. This is 1/4. 1/2. 0, 2, and 4. So it's, when you go back this way, it's 1/2, 1/4. And then at 1, it's 2, and at 2, it's 4. Now when you join those points, dang it, don't go through that. It actually graphs, when it comes infinitely close, does it ever go through there? That's an exponential function. Do you know how bacteria grows? If you have one bacteria doubles every time period. If you go, one bacteria is 2. So you start out with 1. What do you get? They split into 2. So this is 1 bacteria. This is 2. And what are those? Each one of those do? Split again, and you get 4. What do those do? split again, and you get 8 at that level. So you got 1, 2, 4, and then 8. It's called exponential growth. But that's bacteria, that's how come you get sick when you don't take all your medicine, right? They give you antibacterial medicine. You feel good, you quit taking it, and then you get sick really fast because that bacteria starts growing again, doubling. And when it doubles, it really gets, see, a linear equation, straight line linear equation, like this. Exponential looks like that. That's why when you have a credit card, what kind of growth is interest on a credit card? Linear or exponential? Exponential. You pay interest on interest, right? That's exponentially growing. And that's why if you don't pay your interest and you don't pay your credit card, you suddenly get into debt in big time. Right. So if you don't do anything else, when you're paying your bills, pay the interest. Because it can never grow above what that principal is. If you let it go, the next time period, you're paying interest on interest. And then the next time period, if you don't pay it, you pay interest on interest on interest. And that's compounding. Okay, so